Hi, in this lecture, we're going to start looking at some endocrine organs of the body. In this one, we're going to look at the hypothalamus, as well as the anterior and posterior pituitary glands. Now remember that the hypothalamus was the headquarters, right, of the endocrine system and the autonomic nervous system, and that it is connected to the pituitary gland through that thing called the stalk or the infundibulum. The pituitary gland is about the size and shape of a pea, and you might remember that it was located in the sella turcica of the sphenoid bone. Now, the hypothalamus is going to release or secrete releasing and inhibiting hormones, and they all travel from the hypothalamus down to the anterior pituitary gland. So these are our first tropic hormones we'll be learning. Remember, a tropic hormone is a hormone that goes to another endocrine organ and controls what it does, basically the release of its hormones. Now, the hormones from the hypothalamus, as I said, are releasing or inhibiting hormones. So what that means is when they go to the anterior pituitary gland, because remember, the pituitary gland, by the way, is going to have an anterior portion as well as a posterior portion. These tropic hormones only go to the anterior pituitary gland, and they're releasing hormones or inhibiting hormones. So they always end in RH or IH. So we have GHRH. Now that stands for growth hormone releasing hormone. And then there's GHIH, which is growth hormone inhibiting hormone. Now we always write the letters. You'll never write the whole thing out. So we have our first two are GHRH and GHIH. And they go to the anterior pituitary and they control the release of growth hormone. So GHRH says release growth hormone and GHIH says don't release it. We have PRH and PIH. This is for prolactin. So prolactin releasing hormone goes to the anterior pituitary gland and tells it to release prolactin, whereas PIH tells it not to release prolactin. Then we have TRH. Now TRH goes to the anterior pituitary gland and tells it to release TSH, which we'll get to shortly, but that's coming from the anterior pituitary gland. So when TRH is released, TSH is released. So you might wonder, well, what tells it not to release TSH? Well, that's easy. It just doesn't release TRH. I don't know why some hormones actually have an inhibiting hormone, but they do. And so TRH, if it's released, you release TSH. If it's not released, you don't. Then we have GnRH. This is gonadotropin releasing hormone. That's a mouthful. That goes to the anterior pituitary gland and it controls the release of two hormones called FSH and LH. They're called gonadotropins because they're going to go to the gonads ultimately. And then we have CRH, which is corticotropic releasing hormone. That goes to the anterior pituitary gland and triggers the release of ACTH. Now, something interesting is CRH peaks in the morning. So this hormone is highest in the morning, and then it's going to be lowest at nighttime. And so we have this hierarchy here where we have our hormones from our hypothalamus that are going to be releasing or inhibiting hormones to the anterior pituitary gland. When they get to the anterior pituitary gland, again, they release or inhibit the hormone. Some of those are actually tropic hormones that go to another endocrine organ. And what you're seeing here is the thyroid hierarchy. So notice you see TRH goes to the anterior pituitary gland and controls TSH. TSH travels through the blood and goes to the thyroid gland and tells the thyroid gland to release its hormones. So these are also going to use negative feedback because as your final hormone goes up, in this case T3 and T4, it sends feedback back to turn off TRH and turn off TSH. And so you have this system that's in place, or this hierarchy, where you have your hormones from your hypothalamus all going to your anterior pituitary gland and either releasing or inhibiting those hormones from the anterior pituitary gland. So when we come back to the pituitary, as we said, it's in the sella turcica of the sphenoid bone, and there's two lobes here. So there's an anterior pituitary and a posterior pituitary. Now the posterior is called the neurohypophysis, and the anterior is called the adenohypophysis. The neurohypophysis is called this because it's kind of more like a neural tissue. In fact, if you look at it, it looks long and stringy because of all the axons. So it's more like a nervous tissue than an endocrine, whereas the anterior pituitary is a true endocrine organ. You have lots and lots of cells, so it looks very, very dense, and it often stains kind of purple and pink. So let's look at the hormones from the anterior pituitary gland. So we have TSH is our first one. This is a tropic hormone as well because its job is to go to the thyroid gland and tell it to release hormones. So it's going to stimulate the thyroid gland. Now it's under control of TRH, which we just saw. So we're going to have our hierarchy as TRH, TSH, and then you'll see soon the hormones from the from the thyroid are called T3 and T4. So as these hormones go up, right, they're going to come back and they're going to basically turn off TRH. So TRH is inhibited by increased levels of the thyroid hormones. And so we have this hierarchy set up regulated by negative feedback. Okay, now ACTH, long word, adrenocorticotropic hormone, we just say ACTH. So again, it's under control of CRH. When ACTH is released, it's going to go to the adrenal cortex. So it travels to the adrenal cortex and tells it to release your corticosteroids and your glucocorticoids. These are things like cortisol and aldosterone, which you may have heard of. It mainly affects cortisol, by the way. So it's under control of CRH. So the hypothalamus releases CRH. It goes to the anterior pituitary and tells it, hey, release ACTH. And then ACTH goes to the adrenal cortex. So ACTH is another tropic hormone. Now, another thing you're going to see shortly is that stress also affects the release of this. So stress will increase ACTH, which means it will also increase your cortisol and your aldosterone levels. The gonadotropins, right? These are the ones that are basically controlling the gonads. They're controlling the ovaries and the testes. So they're under control of GnRH. Now, GnRH is interesting because it's latent. We don't release it from birth. It's not. It's actually subdued. It's at very low levels, and then it's kind of a mystery still, but when the levels go up, that's what causes puberty. And puberty can happen anywhere from like 9 to 16 years of age. But when this hormone is finally released, it's going to release FSH and LH. So FSH is the first one here that we're looking at from the anterior pituitary. So it's under control of GnRH. And what does it do? Well, it goes to the female and male gonads. So it goes to the ovaries as well as the testes. And so it stimulates the production of estrogen and it stimulates gamete production. So in the eggs, it's going to cause oogenesis, and which is the production of eggs or oocytes. In the male, it's going to cause a formation of sperm, which is called spermatogenesis, and it happens in those coiled tubes inside the testes. Now, inhibin is a hormone released from the testes and ovaries, and it inhibits FSH, so it has its own little feedback loop within it. LH is the other gonadotropin, right? So LH, luteinizing hormone, is triggered from GnRH, and luteinizing hormone mainly tells the gonads to make more hormones. So in particular, it affects progesterone. It helps with some estrogen. It forms what's called a corpus luteum. That's what's called luteinizing hormone. So if you've never heard of a corpus luteum, what happens is once a month, an egg it matures inside the female ovary, and then at ovulation, that egg is released, right? That's ovulated. Well, if we look inside the female, what you'll have is a follicle, and then you'll have the egg. Well, when that follicle ruptures to release the egg, right? Because that's what you ovulate, the ruptured follicle starts to degenerate, and then it makes progesterone. So progesterone is made from that ruptured follicle once it pops and releases the egg. LH also tells the testes to make testosterone, because remember that the interstitial cells in the testes are going to make testosterone. Now, another hormone we mentioned is prolactin. And if we look at prolactin from the anterior pituitary, its main thing is to form the mammary glands and help with milk production, right? For lactation. So it stimulates lactation. Well, it's under control of PRH and PIH. Now, dopamine actually functions as PIH, by the way, to inhibit the formation of prolactin. So you don't make prolactin. PIH is dominant. Prolactin is only released when you're female and you're pregnant. Now, males and females have mammary glands, but men don't lactate. There's no prolactin, and they don't have all the it's not developed as well. The estrogen that's produced and the infant suckling is what actually stimulates the prolactin. And then as you have the suckling, you're going to develop the mammary glands and produce the milk for lactation. And then growth hormone is just what it sounds like. In fact, we've talked about growth hormone a couple times this semester already. So it's called somatotropin. It's made by cells that are called somatotropic cells. So these are the cells inside the anterior pituitary. And it targets, you can see, right, your bones, your cartilage, your muscle, your adipose tissue. It's growth hormone, right? It's anabolic. So it's a tissue building hormone. It's going to do protein synthesis. It's going to build things. And so you have some information here, but let's go to this slide. There's a little more. So what does it do? Well, number one, it affects the liver, and the liver makes these things called insulin-like growth factors. And these are really important for growth, and they actually increase amino acid uptake by your cells to help with your bones and your proteins basically growing, right? Mitosis. So we know it affects our bones and our muscles. So it causes also stem cell divisions in our epithelial and connective tissue because of your bones and muscle are growing, your tendons and your ligaments and your cartilage also needs to increase in size to support that. We know that it increases uptake of sulfur. Cartilage needs sulfur in order to make more cartilage. It mobilizes fat, so it breaks down fat, right? So you burn fat for energy. It slows down using glucose. It's called glucose sparing, so it saves the glucose for your neurons. Remember, neurons need glucose all the time. And it also does glycogenolysis. It breaks down glycogen into glucose. So it's a hyperglycemic hormone. It tries to maintain your blood glucose levels. So it's an awesome hormone, right? You're going to build muscle and you're going to burn fat, which is one reason why it's probably abused, right? Growth hormone is abused a lot of times by athletes to try to get that competitive edge. So we look at our growth hormone levels. We know that's going to cause several different effects. Actually, let me come back for 1 minute to some of the triggers of growth hormone. So things that trigger its release is obviously growth hormone releasing hormone, right, from the hypothalamus. But other things we know is that exercise triggers it, a high protein diet. There's some evidence with fasting, although I'm going to leave that with a question mark. And another thing we know that triggers growth hormone is deep sleep. So it's released when you sleep. And you might have kids and swear that they grew overnight. Well, if you're in a deep sleep, you do release growth hormone. And we also know exercise stimulates its release. And so again, when it's released, it's going to increase all those anabolic effects. Now, the concern with growth hormone, though, is that, as we get older, it decreases with age. So keep in mind, if it's triggered for release by growth hormone releasing hormone, it's going to be inhibited, right, from growth hormone inhibiting hormone. And then it would be inhibited by basically obesity and a lack of exercise or not sleeping. But we also know that as we get older, unfortunately, it's also going to change. It decreases as we age. Now, too much, too little. Lots of endocrine diseases. We're going to look at hyper and hypo. So hypersecretion depends on when it happens. If it happens before that epiphyseal plate becomes the epiphyseal line, right before you stopped growing, we get what's called gigantism. So in gigantism, the child keeps growing and growing and growing. You can be 7 feet tall, right? So that is what's going to happen if it's before the epiphyseal line forms. Acromegaly is something that happens as an adult. So it's too much growth hormone in adulthood. And what it does is it thickens the bones, it thickens the cartilage. And so, you wonder sometimes when you see pictures because it could resemble a professional athlete. We know that professional athletes have abused growth hormone. And I'm not saying that every time you see someone with certain features, it means that they've abused growth hormone. But we do know it tends to increase and enlarge the cartilage on the nose. So the nose gets a little bigger and broader. It causes some changes in the face and the hands. And those are usually irreversible. Now, hyposecretion is just what it sounds like. What if you're not making it? Well, in childhood, then it's going to cause dwarfism. And there's different types of dwarfism, but if it's hyposecretion of growth hormone, you usually are more proportional, but you just don't grow. This is why they do like height and weight charts on babies, because if they notice the child isn't growing, they can give growth hormone supplementary to help with that. And then we're going to finish up with the posterior pituitary gland. So this is special, more nervous tissue, which is why it looks different. It doesn't make hormones. See, the anterior pituitary makes the hormones and releases them. The posterior pituitary gland just stores the hormones that are made up in the hypothalamus. And so if we go back for a second and look at this picture again of the pituitary gland, we'll go up here. Remember that you have these blood vessels that are connecting the hypothalamus to the anterior pituitary. It forms this thing called a hypophyseal portal system. So those releasing and inhibiting hormones from the hypothalamus travel through the blood to the anterior pituitary. But if you look at the posterior pituitary, it's connected with nervous tissue. And the hormones are actually made up in the hypothalamus, and then they're transported to the posterior pituitary where they're stored. So the posterior pituitary doesn't make the hormones. The two hormones we're looking at are ADH, which is sometimes called vasopressin or vasopressin. You might hear it that way. ADH stands for anti-diuretic hormone. You probably know that a diuretic makes you pee a lot, right? So a diuretic would increase your urine output, right? You would urinate a lot. So an anti-diuretic means that it's decreasing your urine output, which is very important. And so what happens is this is monitoring your blood pressure and how salty or how concentrated your blood is. So it's called your blood osmolarity, which refers to the solutes, right? How much stuff is in your blood. And its job is to always watch that to try to maintain homeostasis. Well, we know that the saltiness of our blood should be about 300 milliosmoles. So MOSM stands for milliosmoles per liter. That's where it's supposed to be. So the hypothalamus has receptors. They're called osmoreceptors, and they're monitoring how salty, how concentrated the blood is. If it's too salty, if it's too concentrated, we're going to need to dilute it. And if you have something that's too concentrated, the way you dilute it is you got to hold on to water. So if my blood osmolarity goes greater than 300 milliosmoles per liter, that will be my trigger to release ADH. When that goes up, ADH is released. And then what ADH does is it goes to my kidney. It goes to what's called the nephron in the kidney. And it tells it to hold on to water. So water is going to go back in my blood. And when I put the water back in my blood, I'm going to bring it back down where it's supposed to be, right? So we're looking at the solute concentration and we're going after the kidney because that's where it's controlled. So this is a picture showing you release and inhibiting. So I have my normal concentration. So maybe I ate a lot of salt, or I was sweating a lot, right? That's my stimulus to release ADH anytime I'm dehydrated. So maybe I have a stomach bug and there's vomiting and diarrhea. Maybe you're exercising too much, or not too much, but maybe you're sweating a lot on a hot day, or you're eating a lot of salt. So what happens is the osmolarity goes up, which means you need more water in your blood. So ADH is released, it goes after the kidney, and it decreases your urine output. So if the urine doesn't leave, and if you're decreasing urine output, right? Urine is mostly water. Where's the water go? Well, the water goes into your blood. So it increases your blood volume because the water goes back in the blood, and then that will raise your blood pressure. So how do we inhibit it? Anytime our plasma osmolarity is too low, maybe you're drinking a lot of water. So you drink a lot of water, that dilutes your blood. That goes to your hypothalamus, and now it's like, uh-oh, I'm too dilute. I need to get rid of all this water. So now you increase your urine output. You pee a lot. And when you pee more, you bring your water content back where it's supposed to be. And you can try it on your own. It takes about 45 minutes to inhibit ADH. So drink 2 big glasses of water and set a timer. And you're probably going to have to pee in 30 to 45 minutes because that's how long it takes to inhibit it. We know that alcohol inhibits ADH, especially if you're drinking like watery beer. And so as you inhibit ADH, right, you're going to have an increase in your urine output. You're going to pee more. And then as you urinate more, that's going to dehydrate you. And that's why you get a hangover from it. There is a condition called diabetes insipidus, and in these people, they don't make ADH. Well, that's a problem because if you don't have ADH, you're always going to you're going to pee a lot. So it's called polyuria. So you're going to have a large urine output. Your blood pressure might actually be too low, right? Because all that water's leaving your body and it's not in your blood. So these people have to make sure they're constantly staying hydrated and drinking water because they're losing so much of it. And then we have oxytocin, and oxytocin's kind of interesting. So oxytocin, the main purpose of it, by the way, is to cause uterine contractions and to allow the milk reflex for breastfeeding. So oxytocin, the drug name is Pitocin. So when you're in labor and delivery, and you release oxytocin. In fact, they know the baby actually triggers it first. So the baby determines its due date, its delivery date. And so it releases oxytocin. That makes the uterus contract. And this is an example of positive feedback. When the uterine contracts, you release more oxytocin, and then you get stronger uterine contractions. And then you get more oxytocin, and it intensifies, right? The contractions get harder and closer together. And those uterine contractions are literally squeezing the uterus to get the baby out. And so that's the primary purpose of oxytocin. And it also helps with the letdown. Well, they've discovered a lot more about it recently. So another thing we know that it does is, well, actually several things, is it's associated with bonding. It's called the love hormone because they've done studies and they've seen that when it's produced after you have a baby, it definitely helps with the bonding and the attachment between mother and child. In mothers who don't have the oxytocin, there have been issues with the bonding and they don't form the attachment. They also say it helps with trust and empathy. And so they found some things that release oxytocin and make us feel love and trust and happy. They have found that petting animals does this. So if you have a pet, when you sit and you spend time with your pet, you might feel calmer and might feel better. They know that hugging, touching, intimacy helps increase the release of oxytocin as well. And oxytocin is involved with orgasms, for one thing, in women. That's what causes the uterine contractions for the orgasm. There's some evidence that dark chocolate might increase oxytocin. Maybe that's the link between chocolate on Valentine's Day. I'm not really sure about that one. And then the other thing I wanted to mention is because it causes the uterine contractions, the drug that you may have had to have if you've had a baby is called Pitocin. So that's the drug form of oxytocin, and it stimulates uterine contractions. So if you're having a baby and you're not progressing as fast as they'd like, they might have to give you the drug form, which will really cause some intense uterine contractions for that delivery. So this concludes our lecture on the hypothalamus, the anterior and the posterior pituitary glands.